Mic check. So now we are basically told to evaluate this integral with help of a Cauchy residue theorem. So first step always as usual is just factor out the denominator. So we get, this is a function, okay? So we can write it as the function also if you want. So this is a function, I take this as the function, okay, function. And I'm just simplifying it now. The denominator to be more precise. So we get z square, and if we take z square common, we'll get z square plus 5z plus 6. So basically you get z plus 2 and z plus 3 now. Okay, so this will become z square into z plus 2 into z plus 3. So now the possible analytic points are z is equal to 0, z is equal to minus 2, and z is equal to minus 3. Okay, minus 2, minus 3, and 0. Now if you look at the graph for this question, the graph starts from z is equal to 0 to z is equal to 1z minus 1. So in this region, okay, because we are given this region now, the circle with radius 1 starting from origin. Okay, yeah, okay. So now our points z minus 2 and z is equal to minus 3 would lie outside somewhere. No, minus 2, minus 3. But the only point that lies inside here is z is equal to 0. So the rest of the function is basically constant, like this much part. We only need to evaluate at this. We only have to find one residue. But however, as you can see, the power of this, basically this is of the form z minus z naught raised to n, where z naught is, what do you say? Oh yeah, z naught is 0, no? So 0. We are not concerned with these points, but this point to be more precise. So now, when if we get something of this form now, then we could write it as this, I guess. Yeah, we call it n order pole. So we can write it as the integration of this function is equal to 2 pi I times residue. That is just the normal formula. And for finding the residue at this particular point, residue, we can do this thing. Limit z tending to z naught. Z tending to z naught, I'll put this here. Yeah, okay. Then n minus 1 factor, 1 upon n minus 1 factorial into n minus 1 ka differentiation. N minus 1 time differentiation of that function. And it's multiplied with the same thing. The, what do you call it? The n order pole. So in this case, that would be, what do you say? Yeah, okay, this is a function now. So, and our point or a pole is this. These two are not our poles, only this. And this is a pole of order 2. Because its power is 2, no? That's the only reason, no other reason. See, power is 2. Z square. Yeah. So now we go for finding the residue at z equal to 0. R1 is equal to limit z tending to 0. Now since this is a n order pole, firstly we'll have our factorial term n minus 1 factorial. N ka value is 2, no? N is equal to 2 for this. So 2 minus 1 is 1 factorial into differentiation. N minus 1 time differentiation. If 2, then 1 times differentiate. So 1 differentiation with respect to z of what z minus z naught ka square. Z naught is 0. So basically z square into f of z. Our function is this only, no? We simplified and wrote. So z plus 4 ka square upon z square into z plus 2 into z plus 3. Now if you have a look, these two terms get cancelled completely. This entire thing is in the limit. But first, in order to put, this is normal derivative, okay, not partial derivative. Bruh. Okay. So now we need to put limit z tending to 0. And we need to find the derivative of this. So we'll just use the numerator denominator rule. So, matlab u by v rule, that one. So differentiation of u or numerator, denominator as it is, minus numerator as it is into differentiation of denominator. So now iska differentiation itself is like uv rule wala. So that would be z plus 3 plus z plus 2. Nice, sir. And now we'll have the denominator का square. So इसका square into इसका square. Yeah, now we could just put z ka value 0 now, since we don't have any unanalytic points at the bottom for this. So we'll get this as 2 into 4 into 2 into 3 minus 4 4s are 16. So 16 into 3 plus 2 upon 2 2s are 4. 2 and then if this is 0, then 3 3s are 9. We get this as 4 4s are 16. 16 3s are 48 minus 16 into 5 upon 4 9s are 36. 5 6 are 30 no? So 30 5 ones are 5 80. So you get 48 minus 80 upon 36, which is 48 to 58 68 78 32 by 36. 2 16s are 2 18s are, which is 2 8s are 2 9s are. We get 8 by 9. Nice, sir. This is our residue. Now finally, since there's only one point to check out, okay, so now our integral can be written as by Cauchy residue theorem. I is equal to 2 pi I times the residue. Since we only have one residue, that is all that will appear. 2 pi I into 8 by 9, which is equal to 16 pi I by 9. This is our needed solution.